Welcome back, everyone.
Welcome back, everyone.
In this
To part
lecture, we're
2 of
going
our
to talk about
discussion on
NumPy
NumPy
indexing
arrays.
and
We're going to
selection.
continue right where we left off
Basically,
last time.
indexing is going to allow us to grab a single element from either a one-dimensional array or a two-dimensional array, and selection will allow us to grab a slice or a chunk of elements from a one-dimensional or two-dimensional array. Keep in mind, not everything we show here is going to be used later on in the course, but some of the ideas are going to lay a foundation for things you'll see later on in pandas. Specifically, grabbing a section of time-stamped dates is something we're going to do quite often later on in the course, and it really is a very similar syntax to what we're going to see in this lecture. So let's go ahead and dive right in to our Jupyter Notebook. All right, I've already imported NumPy as NP. To begin with, I'm going to create a very simple array. Just say NP range from 0 to 11, so that should be the numbers 0 through 10. Okay, so starting at 0 all the way up to, but not including 11. First, we're going to show you bracket indexing and selection. So for indexing, let's imagine you wanted to grab a single value from this one-dimensional array. To do that, it works just like a normal Python list. You simply have square braces or brackets, and then you pass in the index location of what you're looking for. So at index location 8, the number is 8, so I should expect to see 8. If you want to get values within a range, just like normal Python list indexing or slicing, you simply, in your square braces, put the start, colon, and then up to, but not including where you want to stop. So if I say 1 up to 5, we get 1, 2, 3, 4. So this is exactly the same way a Python list slicing and indexing works. So let's imagine that I wanted to also grab that 0. I could either do 0 colon 5, or I could say start at the beginning, go all the way up to, but not including, index 5. And the same thing works the other way around, saying start at index 5, and then go up to all the way to the end. And we get something like that. Okay, so that's the basics of bracket indexing and selection for a one-dimensional array. Now, I previously mentioned we can also perform broadcasting. So NumPy arrays differ from normal Python lists because they allow you to broadcast functions and operations across this. So for example, I can grab my array and I can add to every single number in this array. I can divide every single number in this array. And notice the changes aren't permanent. I would have to save this to some new array variable or overwrite my old array variable in order to actually see those effects. So keep that in mind when you're doing operations like this just by itself. You need to reassign the variable to actually see these operations take place. And you can do all sorts of things. So you can even do it to the power. So I can say grab everything in that array and square it, and you'll notice that everything is now squared. So that's general broadcasting. But what's also really interesting, and it's a very important note on slicing, is that a slice is still going to point to the original array. So let me show you what I mean by that. I'm going to create a couple new cells. So here's our original array, 0 through 10. Now let's go ahead and grab a slice of this array. I'll go ahead and create a new variable called slice of array, and then set it equal to array from 0 to 6. So if I check out the slice of my array, notice it's 0, 1, 2, 3, 4, 5. So what I'm going to do is I'm going to broadcast a reassignment to the slice of this array. I'm going to say, go ahead and grab everything in the slice of the array. So that's what that single colon does. It just says grab everything from start to end, and then set it equal to 99. So now if I take a look at my slice of the array, every single element is 99. And what's important to note here is when I did this assignment here in this cell, slice of array is equal to array 0 through 6, it's actually still directly pointing to the original array, which means when I call my original array, notice now that the first 5 elements have all been changed, actually the first 6 elements here, have all been changed to now be 99. So that's sort of broadcasting of a reassignment based off a slice like this that will affect your original array. So always keep that in mind. If you did not want the original array affected, you need to be explicit when creating a copy. So I could say something like array copy is equal to, and the method you would call off your original array is .copy with open and close parentheses. And then here, in your original copy, you could reassign everything to some new value. And we take a look at our array copy versus our original array, And notice the .copy has created a distinct copy in memory. All right, the last two topics we're going to discuss are indexing and selection on a two-dimensional array, and then conditional selection based off some sort of Boolean condition. So first off, let's talk about indexing on a two-dimensional array, otherwise known as a matrix. So I'm going to create a two-dimensional array by saying arr underscore 2d is equal to np array, and let's go ahead and just pass in a nested list. So we can say 5, 10, 15, and then just keep in mind the braces here, 20, 25, 30, and then finally let's say 35, 40, 45. Okay, so if I take a look at this two-dimensional array, I see 5, 10, 15, 20, 25, 30, 35, 40, 45. I can also, as a reminder, check the shape of this to see that it's a 3 by 3. Now, the general format for actually indexing or grabbing items, rows, or columns from an array is you say the index of the row first and then the index of the column. So if I just want to grab a single item, I will say in square braces the row I'm interested in. So for example, index 1, and indexing starts at 0 just like everything else in Python. So row 1 is this one right here, 20, 25, 30. So we have index 0, index 1, index 2. So if I just say this, it returns back the row at index 1. Now, notice I can perform the same sort of logic I did at first with a one-dimensional array. So let's imagine I wanted to grab 25. Well, that's also at index 1, so that's 0, 1, which means I just need another set of braces. And there is 25. Now, if you wanted to, the other way to write this out is with a comma. I could say 1, 1 inside the same set of braces, and that will also give me back 25. All right, so see if you can pause the video and grab the number 45 from this 2D array. So, continuing on, how would we actually do that? Well, I can see that it's at row 2 at column 2. So I simply need to say 2, 2, and there's 45. Now let's imagine I actually wanted to grab a selection of more than just one number. Well, I can actually perform 2D array slicing with the same sort of logic. So for example, let's imagine I wanted to grab 10, 15, and 25, 30 as a little subset square. Well, the way I can do that, and I'm going to go ahead and print out the array here, is array underscore 2D. I'll go ahead and pass in the slice of the rows I want. I want rows 0 and 1, which means I want everything from the beginning up to and not including in row 2. So if we just see this and run that, I can see that this gives me back the first two rows. Row at 0, row at 1, because it's a slice. It goes up to, but not including 2. And then, if I want 10, 15, 25, 30, then basically I want to start at index 1 for the columns all the way to the end. So I go 1, colon, all the way to the end, and then 10, 15, 25, 30. Now I know this can seem pretty advanced and it's a little confusing at first, so what I would highly recommend is checking out our notebook where we have a nice little image for you that has a lot of information about slicing with step sizes and slicing individual chunks out of a two-dimensional array. Keep in mind, for our use cases in this time series course, we're really not going to be doing this sort of grabbing of two-dimensional chunks from a two-dimensional array that often. So don't worry too much if this sort of slice notation confuses you. You really won't have to do it that often in the course. In fact, this is probably the only time you're going to see it in this course. Okay, so again, you can check out the provided notebook for more examples. But the last thing I want to show you is conditional selection. And that's something that's actually really important, especially in pandas. So conditional selection is a fundamental concept that directly translates to pandas, and it allows you to use comparison operators to actually grab elements. So I'm going to show you this in multiple steps. Let's go ahead and create our new array. We'll go 1 to 11, meaning our array is the numbers 1 through 10. And we can actually perform a Boolean comparison by simply saying, where is the array greater than 4? And this returns back a NumPy array full of Booleans. So it just goes for every single number and broadcasts that comparison operator. So is 1 greater than 4? Well, that's false. Is 2 greater than 4? That's false. And so on until it hits 5, and then that's true. Now what I can do is I could say my Boolean array is equal to array greater than 4. And now I have this nice Boolean array object. And then I can perform conditional selection by actually passing in this Boolean array as a filter to my original array. So I call my original array, call square braces, and then pass in that Boolean array. And notice it's only going to return back where the index locations were true. So all NumPy is doing here is it's taking a look at your Boolean array, false, 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 true, 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 and so on. And it's saying, okay, you have a false at index 0, so I won't return that. You have a false at index 1, so I won't return that, and so on until it sees a true. It notes the index location and then returns back the element at that index location for the original array. So that would be 5, 6, 7, 8, 9, 10. So typically, people aren't going to do this in multiple steps like this. They won't define a separate Boolean array. Instead, what you're typically going to see is something like this, the array, and then you'll say where array is greater than 4. And that's the exact same thing, just all done in one step. And this is the sort of operation we're going to see all the time in pandas. Pandas has conditional selection in the exact same way, and it looks very, very similar to this. And later on, we'll learn how to do multiple conditions, like less than 4, but greater than 2 or something like that. But for right now, we can see that we can just do very simple conditional booleans. So I can say, for example, where the array happens to be equal to 2. And in that case, it'll just return back one item, 2. Or I can say less than or equal to 6. Whoops. And then I get 1, 2, 3, 4, 5, 6. Okay, so again, you have some sort of comparison operator against the entire array, and then you just pass that in as a condition inside square braces. So that's all you need to know for conditional selection and then indexing and broadcasting and selection across arrays. Coming up next, we're going to be talking about some NumPy operations that are very useful, and after that, we'll set you loose on some exercises. Thanks, and I'll see you at the next lecture.